Just a reminder about class diagrams and the syntax of class diagrams. So if we have an attribute in a class diagram that has no type, we can just write attr, so that would be the attribute's instance name. If it has a type, we can mention its data type. And if it's a bunch of attributes, that is an array, we can give it some kind of a multiplicity. So these represent the kinds of attributes we might see. We can also have operations with no return value, operations that are of kind data, that return kind data type, and operations that take an attribute or more than one attribute of kind data type and return type data type. So this is a sort of a generic way that we can write the features of our class. So our class has a name, and then we have some pieces that describe the attributes of our class, and then we have some that describe the operations of our class. So the combination of attributes and operations we call features. And features tell, for example, the kind of messages that our class can respond to, as well as the kind of data values that it has that makes up its state. Okay, so now that we've seen the kinds of things that are in a class, we can begin to talk about the kinds of semantics that we have when we want to compose classes in some way. And one of those semantics is the so-called is-a semantics that comes with inheritance. So we represent inheritance with a triangle like this between two classes, a line with a triangle at the end. The triangle side is touching the superclass, and the subclass has the association that just ends in a but. So in this case, we say that the subclass is a superclass. And by is-a, that's what we mean semantically, that these are the following characteristics of a subclass. So any features of a superclass are features of the subclass. The subclass can receive any message that superclass can receive. This, by the way, comes from the fact that objects of the same kind can receive the same message, or objects of the same type can receive the same message. That's one of the 5 fundamentals of OO. So if the subclass is a superclass, then if a message can be received by the superclass, the subclass is a superclass and therefore must be able to receive those messages. And this leads to something that we call the polymorphic substitution principle, which is that anywhere you can use superclass, you could use subclass instead. So if you have a method that takes a superclass as a parameter, then you could send an instance of a subclass instead.